Welcome to the sleepy atom, where bedtime drifts into the mysteries of the universe. Tonight we are stepping into a question so vast it almost feels impossible. What existed before the Big Bang? Scientists say our universe is about 13.8 billion years old, but that number only tells us how long ago the clock started ticking. What about the silence before clocks, before stars, before even space itself? Was there a nothingness? Was there something we simply cannot picture? The question has puzzled philosophers, scientists, and dreamers for centuries. Tonight, as you rest, let us gently wander back toward that unseen horizon. The silence before time. Imagine standing on the edge of a cliff, but instead of looking down, you are looking back before galaxies, back before atoms. All you see is silence. Not darkness, not emptiness, but a kind of silence that even our language struggles to describe. This silence isn't the silence you hear when you close your ears. It's deeper than that. It's the absence of sound, but also of anything that could carry sound. A silence where even the idea of before loses its meaning. Scientists call this the singularity, but even that word can be misleading. A singularity is not really a thing. It's a placeholder for the limits of our understanding. Beyond it, the math we trust so much begins to dissolve, as though numbers themselves can't survive the silence. And yet something about this silence stirs us. Why? Because in that pause before the first cosmic breath lies the possibility of everything. It's the moment the universe held its breath, waiting, holding, almost dreaming. When we imagine that silence, we may wonder, was it truly empty? Or was it filled with a hidden hum that no one could hear? A hum that would one day blossom into stars. Was there ever a before? Here's the puzzle. To even ask what was before the Big Bang may already be a mistake. Because before is a word tied to time, and time itself was born in the explosion. So can we speak of a before when there was no time ticking to measure it? Think of a book. The first page is where the story begins. If you ask what page comes before page 1, you may realize the question doesn't make sense inside the book. Page 1 is the starting point. Maybe the universe works the same way. But the mind resists this. We feel that something must have led into the story. A song has an opening note, a river has a spring. Can a universe really just appear without a prelude? The discomfort is a kind of mirror. It shows us how deeply time is stitched into our thinking. Physicists like Stephen Hawking once suggested that the universe may have no boundary, like the surface of a sphere. You don't ask what's north of the North Pole. In the same way, asking before the Big Bang might be chasing a shadow.
Yet shadows matter, don't they? Even if they cannot be grasped, they remind us of shapes hidden just out of sight. And maybe, just maybe, those shapes belong to something real. The edge of human imagination. Every time we talk about the Big Bang, we also meet the edges of our own imagination. Human minds evolved to picture rivers, trees, skies. We didn't evolve to picture timeless voids or dimensions curled into silence. And yet, we try. When you sit quietly and imagine nothing, your mind still fills it with something. Darkness, perhaps, or an empty room. But true nothing is not even blackness. It is the absence of anything that could be black or white. It slips through our fingers the moment we think we've grasped it.
This is why ancient stories often used symbols and myths. They gave faces and voices to the unimaginable, a cosmic egg, a serpent in the void, a god breathing stars into existence. Each myth was not a literal answer, but a doorway through imagination into the unthinkable. Modern science, in a way, is not so different. Instead of serpents and eggs, it gives us singularities and quantum fields. But the truth is the same. we are still trying to paint pictures of a place where our canvas may not even exist. And yet, don't you feel that pull, that quiet sense that even if our minds cannot fully imagine it, something was there? Something always was. Space without space. The Big Bang is often pictured as an explosion in space, but it wasn't an explosion in space. It was the explosion of space. That small shift changes everything. Before it, there was no outside into which the universe expanded. Think of a balloon. When you blow air into it, the surface stretches. Now imagine that surface as space itself. The balloon doesn't expand into a room. It expands by creating more surface. That's what space did at the Big Bang. And so outside is a word that doesn't quite fit. If there was no outside, then what about before? Perhaps before space is like asking where the balloon was before it was even a balloon. Maybe it wasn't anywhere. It simply wasn't yet. This is what makes cosmology both thrilling and unsettling. We want to point our finger somewhere, to say it began there. But with space itself being born in the bang, there may be no there to point to. We are trying to use tools built for geography in a land with no maps. And yet this very strangeness sparks the imagination. If there was no space before, does that mean there was no limit either? Could everything we know have unfolded from something limitless? The puzzle of nothingness. Here's a paradox that keeps even scientists awake at night. What we call nothing might be far from empty. In physics, even a vacuum is restless, bubbling with fleeting particles that flicker in and out of existence. So is nothing really nothing at all? Think of the calm surface of a pond. To the eye, it looks still, but underneath are ripples, movements, tiny creatures stirring. The universe's nothingness may be the same, quiet to us, but secretly alive with possibility. Quantum theory suggests that this restless vacuum could, under the right conditions, give birth to a universe. A spark from the so-called nothing igniting into everything. It sounds impossible, yet the math dares to whisper it could be true. And if that is the case, then maybe the Big Bang was not the beginning of something from absolute nothing, but the blossoming of something from a deeper, invisible sea of potential. The nothing was never truly empty, which leaves us with a haunting thought. If nothing is never truly nothing, then could universes be rising and falling all around us right now, hidden just beyond what we can sense? When physics breaks down, there's a point where our equations simply fall apart. The closer we push back toward the Big Bang, the more our trusted rules begin to tremble. Gravity pulls one way, quantum mechanics another. Instead of harmony, we meet a clash, a place where human knowledge shatters like glass under pressure. Physicists call this a singularity, but that's just a word. What it really means is we don't know. Our greatest minds, armed with the sharpest math, find themselves staring into a fog. And that fog is not a dead end, it's a doorway. One that whispers of deeper laws still hidden. It's unsettling to think the very laws that govern the stars and planets may not have existed in that earliest moment. Imagine building a house where the bricks don't yet know how to be solid. That's what the birth of the universe may have been. A time when matter and energy had not yet agreed on the rules. Some scientists dream of a theory of everything, a single set of laws that can bridge gravity and quantum mechanics. If we could see through the fog, perhaps we would glimpse that theory shining like a lighthouse in the dark. But until then, we live with the mystery, and maybe that's its own kind of gift, because when physics breaks down, imagination begins. And where imagination begins, so do new worlds of possibility, a universe without clocks. Close your eyes and try to picture a world without time. No ticking, no passing seconds, no before or after. Just a stillness that cannot be measured. For us, time is the rhythm of life. Without it, how can anything exist at all? This question haunts cosmology. If time began with the Big Bang, what did the word earlier even mean? Some physicists suggest that the universe, before time, was in a state of timeless quantum stillness, a frozen possibility not yet moving, waiting for the spark that would awaken duration. Think of a song before the first note is played. The melody exists in potential but not yet in sound. That is how some scientists describe the pre-Big Bang reality. Not a sequence of moments, but a timeless field of possibility humming just below perception. It raises another question. Does time only exist for beings like us, who count days and measure change? Could the universe itself be indifferent to time, existing in ways our minds cannot capture? If true, then the universe may not have a before at all. It may simply be timeless, always present, always here, without needing a clock to prove it. The ghost of quantum foam. When we peer into the smallest scales of reality, we find that emptiness isn't empty. It writhes, it foams. At the tiniest level, space is not smooth, it bubbles like boiling water. This strange turbulence is called quantum foam. In this foam, particles appear and vanish in flickers shorter than a heartbeat. It's restless, unpredictable, and alive with possibility. Some physicists wonder if the Big Bang itself could have been a ripple, a sudden swell in this eternal sea of foam. It's dizzying to think that our galaxies, our stars, even us, may all be the aftermath of a flicker, a moment when the foam boiled over and reality as we know it spilled out. Was it chance? Was it inevitable? The foam keeps its secrets. What fascinates scientists is that quantum foam may not belong to time as we know it. It exists at scales so small that the usual rules of before and after simply collapse. In that sense, it could be the eternal canvas upon which universes occasionally appear. And if the foam is eternal, then perhaps the Big Bang wasn't the first. Perhaps it was just one bubble among countless others, rising and vanishing in silence. Energy waiting to awaken. Another vision. Before the bang, there was not nothing, but energy. Not the kind of energy that warms your hands or powers your lights, but a raw, undifferentiated energy, resting in stillness. This energy, physicists suggest, could have been trapped in a vacuum state, balanced so perfectly it seemed motionless, but like a ball perched on a hilltop, even the smallest tremor could have sent it rolling, releasing a flood that became space, time, and everything within them. It's a haunting picture, a universe not sparked by chaos, but by the quiet inevitability of potential finally tipping into becoming. Almost like destiny, written not in prophecy but in physics. Some cosmologists wonder if this potential energy exists even now, everywhere, hidden in the fabric of space. If so, then our universe may not just have been born from it, it may still be fed by it, moment by moment in ways we cannot see. And if energy was always there, then maybe the Big Bang wasn't a beginning at all. Maybe it was just the awakening of something that had been quietly waiting all along, echoes that never spoke. If the universe was born in fire, did it leave whispers behind? Physicists study the faint glow called the cosmic microwave background, an afterglow of the Big Bang. But what about before that glow? Did earlier echoes exist too faint to survive the birth? Some theories suggest that if there were universes before ours, their final sighs might still hum faintly, buried in the static of the cosmos. A kind of ghost song, too subtle for our instruments, but woven into the silence itself. It's an eerie thought. We live surrounded by possible echoes of realities long gone, echoes that never spoke clearly, never announced themselves, yet still linger like the faint smell of smoke after a fire. Searching for these echoes has become one of science's great quests. If we could find them, we might prove that our universe is not alone, Not the first, not the only. We might glimpse a history older than history itself. And even if we never find them, the idea itself lingers like a shadow, suggesting that our universe may not be a single story, but a verse in a much older song that has always been singing. The mystery of the cosmic egg. Long before telescopes and equations, humans dreamed their own answers to creation. One of the oldest is the idea of the cosmic egg. Many cultures imagined the universe as an egg that cracked open, spilling out the sky, the earth, and life itself. In Hindu texts, it was called the Hiranyagarbha, the golden womb. In ancient Greece, Orphic myths spoke of a shining egg born from night and chaos. Even in China, stories told of Pangu emerging from a cosmic shell, shaping heaven and earth with his body. What's fascinating is how universal this symbol became. Separate cultures, oceans apart, pictured beginnings not as explosions but as openings. An egg does not shatter chaotically, it unfolds with life. Could that be an intuitive echo of the universe's expansion? Scientists today may not use the word egg, but they too speak of singularities and compressed beginnings where everything that ever was lay hidden in a seed-like state. The poetry of myth and the rigor of science suddenly feel closer than we expect. Perhaps that's why the cosmic egg still lingers in our imagination. It reminds us that the start of everything may have been less like a bang and more like a birth. Ancient myths about origins. Every civilization carried its own story of beginnings. To the Norse, the world was carved from the body of a giant. To the Egyptians, a lotus blossomed on the waters of chaos, and from it the first god emerged. To the Mayans, the gods spoke creation into being with words. These myths may sound like poetry, but they reveal something profound. Humans could not bear the thought of nothingness. They needed a spark, a gesture, a breath to begin the story. Even when they didn't agree on the details, they agreed there was a beginning worth telling. In a way, these myths mirror science. Each tries to translate the unimaginable into images the human mind can hold. Where myths speak of giants and lotuses, science speaks of particles and singularities. Both are languages reaching for the same horizon. And sometimes the myth carries wisdom. Science later rediscovers the Mayans imagined sound shaping the universe. Today, physicists study cosmic vibrations, gravitational waves, sound like ripples across space-time itself. The boundary between myth and science is not a wall, it is a bridge, one made of questions, imagination, and the desire to find meaning in the silence before the dawn. The Hindu idea of endless cycles. Not all traditions believed in a single beginning. In Hindu cosmology, the universe is born, dies, and is reborn in endless cycles. Each cycle spans unimaginable ages called kalpas, like breaths of a sleeping god. This idea of eternal cycles feels strikingly modern. Some cosmologists now explore cyclic models of the universe, where expansion leads to contraction and collapse leads to new birth. The universe becomes not a one-time event, but a rhythm, a cosmic heartbeat pulsing forever. In the Hindu vision, there is no ultimate beginning, only endless transformations. Time itself is circular, not linear. This stands in sharp contrast to the Western idea of a single creation followed by a final end. What makes this fascinating is how it resonates with new physics. Some theories suggest the Big Bang may have been the bounce back from a previous collapse, an echo of an earlier universe now forgotten but whose ashes seeded our own. Perhaps the Hindu seers sitting under night skies thousands of years ago glimpsed a truth science is only beginning to rediscover, that creation is not a single act, but a dance without end. The Greek dream of eternal return. The Greeks, too, dreamed of cycles. They spoke of the eternal return, where worlds rise and fall endlessly, repeating across infinite time. Heraclitus hinted that fire was the eternal element, burning and rekindling itself forever. This vision of eternal return fascinated later philosophers as well. Nietzsche revived it, asking, what if everything we live now will repeat again, endlessly? It was not just a cosmological idea, but an ethical one. How would you live if you knew every moment would return? Modern science echoes this with ideas of eternal inflation, where bubble universes form, expand, and fade, while new ones continue sprouting in the background. No single universe is permanent, each is a flicker in an eternal process. In a way, the Greek imagination and modern cosmology converge. Both suggest that reality may not have a final chapter. Instead, stories repeat in endless variations, each universe both unique and yet part of a greater pattern. And when you look at the stars tonight, it is humbling to think, this story we are living may have been told countless times before and may be told countless times again. Science meets the old stories. It's tempting to draw a sharp line between myth and science. One is story, the other is truth. But when you look closely, the line blurs. Both are attempts to answer the same haunting question: where did all of this come from? The cosmic egg, the lotus, the eternal cycles. They were not random tales, they were humanity's early equations, poetic formulas written in the language of symbol and dream. They gave comfort, structure, and meaning, even when no evidence could be weighed. Science, with its telescopes and particle accelerators, may use different tools, but the impulse is the same. Both myth and physics reach into the unknown, pulling back fragments of light to make sense of the dark. And sometimes the parallels are startling. The myth of cycles finds echo in bouncing cosmologies. The Mayan vision of sound resonates with modern studies of cosmic waves. Perhaps the old stories carried whispers of truths too deep for their time. So when science meets myth, it is not a dismissal, it is a reunion. Two ways of seeing, finally acknowledging that they were always walking the same path, chasing the same mystery that began before beginnings. Inflation without a trigger. The Big Bang itself was only the opening act. Right after it, the universe seems to have gone through something even stranger. Inflation. In a tiny fraction of a second, space ballooned faster than the speed of light, stretching everything smooth and vast. But here's the puzzle: what triggered this? We can trace the math of inflation, but the spark itself remains a ghost. It's as though the universe suddenly decided to run, without anyone firing a starting gun. Think of a calm pond that suddenly surges into a tidal wave. Something pushed it, something hidden. Inflation may have been the same, a storm ignited in silence, one we still cannot explain. Some physicists suggest that inflation might not need a trigger at all, that perhaps the energy of the vacuum itself naturally swells and bursts, as though the universe was primed to expand the moment it was born. If true, then the mystery deepens. Maybe universes are not rare miracles, but natural consequences, like seeds sprouting wherever soil and rain meet. If inflation is built into the fabric of reality, then creation itself may be inevitable. Eternal inflation. Worlds without end. Inflation did not just stretch our universe. According to some theories, it never really stopped. While our corner of space slowed down into galaxies and stars, other corners kept inflating endlessly. This gives rise to an extraordinary vision: eternal inflation, a cosmic landscape where bubbles of universes constantly appear, like foam spreading across an infinite sea. Our universe, with all its stars and galaxies, may be just one bubble among countless others. In this endless expansion, there is no final horizon, no edge, just new worlds continually blossoming, each with its own laws, its own constants, its own stories written into physics itself. It's dizzying to picture. Imagine standing on a hill, watching soap bubbles appear one after another, drifting and vanishing. Now imagine each bubble is a universe containing suns, planets, maybe even beings wondering about their own beginnings. If eternal inflation is real, then our cosmos is not unique. It is part of a vast, endless garden. And in that garden, creation is not an event. It is a process that never ends. Baby universes sprouting in silence. Some scientists take this even further. They suggest universes might be born within other universes. A black hole in our cosmos, for example, could collapse inward, and in that collapse sprout a new universe on the other side. If so, then every galaxy's heart, every swirling black hole, could be a cosmic womb. And from within those wombs, baby universes spill out, each with its own space, its own time, hidden from ours but real in their own right. It's a strange thought. Our universe itself may have been born this way, perhaps from the ashes of another collapsing into silence, and then flowering outward into ours. We could be the child of a forgotten parent universe. This changes the meaning of beginnings. The Big Bang is no longer a solitary miracle, it becomes part of a family tree. A branching of universes, each giving rise to the next, like an endless lineage of stars. And just as children inherit traits from parents, maybe universes pass on subtle fingerprints, constants, patterns, whispers, reminders of where they came from, even if they never meet again. Black holes as gateways. Black holes are usually pictured as devourers, cosmic monsters swallowing everything that strays too close. But what if they are also gateways? Some physicists speculate that beyond the event horizon, space doesn't simply end. Instead, it folds into a new beginning. This idea is radical, but it solves a haunting question. What happens to information swallowed by a black hole? If nothing is lost in the universe, perhaps that information is recycled into new worlds, encoded into the seeds of baby universes. Imagine falling into a black hole. To an outside observer, you vanish, but from another perspective, maybe you are crossing into a newborn cosmos where the laws are just being written. This vision reshapes our place in the cosmos. Black holes are no longer just tombs. They are midwives carrying universes into existence, hidden beyond horizons we cannot cross back from. And if so, then every black hole we see, twinkling in distant galaxies, may also be a silent doorway behind which new universes are taking their first breaths. A multiverse without borders. When you gather these ideas, inflation, baby universes, black hole gateways, you arrive at something breathtaking. A multiverse. Not one universe, but many, perhaps infinite. Each with different beginnings, different endings, different rhythms of time. In one universe, stars may never form. In another, life may bloom in ways we cannot imagine. Some universes may last forever, others may flicker out in an instant. Together they form a tapestry without borders, endlessly branching and expanding. If this is true, then our own universe is just a note in a symphony, a melody we happen to hear, but not the whole song. The greater song may be infinite, stretching beyond any horizon. It makes you wonder, are we unique, or are there countless beings in countless universes looking up at their own skies, asking the same questions we asked tonight? The multiverse doesn't answer, it teases like a shadow just beyond reach. And maybe that's the beauty. Our universe may not be the whole, but it is our home, our story. And in the silence between stars, it whispers that creation never truly stops. It only changes its form, strings vibrating in the void. Imagine that beneath all particles, protons, electrons, even quarks, there is something smaller, not tiny dots, but vibrating strings. According to string theory, the universe is not built from points, but from loops of energy humming like the strings of a violin. Each vibration produces a different particle, just as each note on a string produces a different sound. Matter, forces, light, all of it could be music born from these hidden strings. The universe itself in this vision is not a machine, but a symphony. The idea is poetic, but also radical. Strings are unimaginably small, so small that no current experiment can directly observe them. They exist in the shadows of theory, suggesting a hidden layer beneath everything we know. If true, then before the Big Bang, these strings may have already been vibrating, their music building the foundations of what would become reality. The nothingness may have been alive with silent notes, and suddenly the question of what came before the bang transforms. Perhaps it was not emptiness, but a cosmic orchestra waiting for the curtain to rise. The hidden dimensions. For string theory to work, it requires more than the 3 dimensions we see. It whispers of hidden ones, 6, 7, maybe more, curled up so tightly we can never notice them, like tiny hallways folded into the walls of existence. Imagine walking through a house and finding secret rooms behind the wallpaper. That is how physicists describe these hidden dimensions, always there, but too small to enter. Yet within them, the deepest truths of the universe may be stored. Some suggest these dimensions existed before the Big Bang, shaping how the explosion unfolded. The angles, the constants, the forces we see today may have been born from the way these hidden spaces were curled. It is humbling to think the laws of physics, which feel so permanent, might actually be fingerprints of dimensions we will never see. Our entire universe may be the shadow of deeper spaces just beyond perception. And if that's true, then the bang wasn't the first page of the book. It was only the moment the book opened to us. Brains colliding in the dark. String theory doesn't just give us strings, it also gives us brains, short for membranes. These brains can be enormous, like sheets of reality floating in higher dimensions. Our universe itself may be one such brain. Now imagine 2 brains drifting silently in the dark. For eons they remain apart. Then, one day, or one timeless moment, they collide. The impact unleashes unimaginable energy, an explosion of space and time. That collision, some scientists believe, could have been our Big Bang. In this picture, the bang was not the birth of everything, but the consequence of 2 pre-existing worlds touching, a cosmic accident or perhaps an inevitability. In a space where brains endlessly drift, it raises unsettling possibilities. If collisions create universes, then perhaps they happen again and again. Or maybe right now, far beyond what we see, another collision is preparing, birthing another cosmos in silence. This brain-world theory stretches imagination to its limits, but it also offers comfort. The universe may not be an isolated miracle, it may be one of many sparks in a grander, ongoing dance. When 2 universes touch, the idea of colliding universes reshapes how we think of beginnings. Instead of nothing becoming something, we picture 2 great surfaces brushing against each other. Their meeting ignites creation, not from emptiness, but from contact. Think of 2 cymbals clashing in an orchestra. For a moment, there is silence, then collision, resonance, sound. Perhaps our universe was born in such a clash, not of instruments, but of cosmic brains. If so, then the echo of that touch may still ripple through our skies. Some scientists even search for scars in the cosmic microwave background, patterns that could be fingerprints left from another universe brushing ours. The thought is eerie. It suggests that our universe may not be self-contained, but part of a greater landscape where entire realities touch, separate, and sometimes give birth to new worlds. And maybe, just maybe, the bang was not a beginning at all, but a handshake between two universes in the dark, cycles of expansion and collapse. There's another idea that brings us full circle. What if the universe itself breathes, expanding in a great outward sweep, then collapsing back in, only to burst forth again? Expansion, collapse, expansion, an endless rhythm of birth and death. This cyclical model suggests that the Big Bang was not the first, but one in an infinite series. Each universe gives way to the next, like seasons turning endlessly through cosmic time. In such a vision, nothing is final. Even collapse is not an ending, but a preparation for new birth. Just as winter carries the seed of spring, so does cosmic death carry the seed of rebirth. If true, then time itself may not be a line, but a circle. And every star, every galaxy, every life, including ours, may be part of a cycle older than memory, older than imagination. There's something strangely comforting in that. The universe does not vanish, it renews, and we, as fragments of it, may be part of a story that endlessly begins again. Strings vibrating in the void. Imagine that beneath all particles, protons, electrons, even quarks, there is something smaller, not tiny dots, but vibrating strings. According to string theory, the universe is not built from points, but from loops of energy humming like the strings of a violin. Each vibration produces a different particle, just as each note on a string produces a different sound. Matter, forces, light, all of it could be music, born from these hidden strings. The universe itself in this vision is not a machine but a symphony. The idea is poetic but also radical. Strings are unimaginably small, so small that no current experiment can directly observe them. They exist in the shadows of theory, suggesting a hidden layer beneath everything we know. If true, then before the Big Bang, these strings may have already been vibrating, their music building the foundations of what would become reality. The nothingness may have been alive with silent notes, and suddenly, the question of what came before the bang transforms. Perhaps it was not emptiness, but a cosmic orchestra, waiting for the curtain to rise. The hidden dimensions. For string theory to work, it requires more than the 3 dimensions we see. It whispers of hidden ones, 6, 7, maybe more, curled up so tightly we can never notice them. Like tiny hallways folded into the walls of existence. Imagine walking through a house and finding secret rooms behind the wallpaper. That is how physicists describe these hidden dimensions, always there, but too small to enter. Yet within them, the deepest truths of the universe may be stored. Some suggest these dimensions existed before the Big Bang, shaping how the explosion unfolded. The angles, the constants, the forces we see today may have been born from the way these hidden spaces were curled. It is humbling to think the laws of physics, which feel so permanent, might actually be fingerprints of dimensions we will never see. Our entire universe may be the shadow of deeper spaces just beyond perception. And if that's true, then the bang wasn't the first page of the book. It was only the moment the book opened to us. Brains colliding in the dark. String theory doesn't just give us strings, it also gives us brains, short for membranes. These brains can be enormous, like sheets of reality floating in higher dimensions. Our universe itself may be one such brain. Now imagine 2 brains drifting silently in the dark. For eons they remain apart. Then one day, or one timeless moment, they collide. The impact unleashes unimaginable energy, an explosion of space and time. That collision, some scientists believe, could have been our Big Bang. In this picture, the bang was not the birth of everything, but the consequence of two pre-existing worlds touching. A cosmic accident, or perhaps an inevitability, in a space where brains endlessly drift. It raises unsettling possibilities. If collisions create universes, then perhaps they happen again and again. Maybe right now, far beyond what we see, another collision is preparing, birthing another cosmos in silence. This brain-world theory stretches imagination to its limits. But it also offers comfort. The universe may not be an isolated miracle. It may be one of many sparks in a grander, ongoing dance. When two universes touch, the idea of colliding universes reshapes how we think of beginnings. Instead of nothing becoming something, we picture two great surfaces brushing against each other. Their meeting ignites creation, not from emptiness, but from contact. Think of two cymbals clashing in an orchestra. For a moment there is silence, then collision, resonance, sound. Perhaps our universe was born in such a clash, not of instruments but of cosmic brains. If so, then the echo of that touch may still ripple through our skies. Some scientists even search for scars in the cosmic microwave background, patterns that could be fingerprints left from another universe brushing ours. The thought is eerie. It suggests that our universe may not be self-contained, but part of a greater landscape where entire realities touch, separate, and sometimes give birth to new worlds. And maybe, just maybe, the bang was not a beginning at all, but a handshake between two universes in the dark. Cycles of expansion and collapse. There's another idea that brings us full circle. What if the universe itself breathes, expanding in a great outward sweep, then collapsing back in, only to burst forth again? Expansion, collapse, expansion, an endless rhythm of birth and death. This cyclical model suggests that the Big Bang was not the first, but one in an infinite series. Each universe gives way to the next, like seasons, turning endlessly through cosmic time. In such a vision, nothing is final. Even collapse is not an ending, but a preparation for new birth. Just as winter carries the seed of spring, so does cosmic death carry the seed of rebirth. If true, then time itself may not be a line, but a circle. And every star, every galaxy, every life, including ours, may be part of a cycle older than memory, older than imagination. There's something strangely comforting in that. The universe does not vanish, it renews, and we, as fragments of it, may be part of a story that endlessly begins again. As we open more of this journey, we'll step into time as a circle, entropy's arrow, and the haunting question of whether time itself can run backwards. Time as a circle, not a line. We often picture time as a straight path, stretching from past to future. But what if time is not a line at all? What if it's a circle, endlessly looping, without a true beginning or final end? This idea unsettles our everyday sense of cause and effect. A circle of time means that what we call yesterday and tomorrow may not be separate. They may be neighbors on a wheel turning again and again. Ancient cultures saw time this way. The Maya, Hindus, even early Greeks spoke of cycles rather than lines. Birth, death, rebirth. Not a story told once, but endlessly retold. Modern physics has begun to whisper similar possibilities. If universes collapse and bounce back, or if cosmic cycles repeat through inflation, then time itself might be circular, a rhythm, not a march. And if that is true, then perhaps the Big Bang wasn't the first dawn. It may simply have been the latest sunrise in a cosmos that has always turned, always returned, the phoenix universe rising again. Imagine a phoenix burning to ash, only to rise again in fire. Some scientists see the universe in the same way, a cosmos that expands, collapses, and is reborn, endlessly rising from its own ashes. This Phoenix universe model suggests that the Big Bang was not a beginning, but a rebirth, a flame rekindled after collapse, the death of one universe feeding the birth of another. It's a hauntingly beautiful vision, galaxies collapsing into darkness, then light surging forth once more, the cosmos breathing, pulsing like a living being too vast to comprehend. In this picture, entropy, the tendency toward disorder, does not spell doom. Instead, collapse gathers everything together, preparing the way for another ignition, another cycle of order and chaos. Perhaps we are not the first to ask these questions under the stars. Perhaps countless civilizations in countless previous cycles once wondered the same, their voices carried into silence before the next dawn returned. Entropy and the arrow of time. Every day we see it. A glass shatters, never reassembling. Smoke disperses, never flowing back into the fire. This is entropy, the measure of disorder, and it gives us the arrow of time. Entropy always increases. It is why the universe moves forward, why moments cannot be rewound. Without entropy, there would be no sense of past and future, only stillness. Entropy is the drumbeat of time itself. But what about before the Big Bang? Did entropy exist? If time itself began there, then entropy had no past to build upon, which makes scientists wonder, how did order arise in the first place? Some believe the Bang was born in a state of extreme order, perfect smoothness, that then unraveled into complexity. Others think entropy is eternal, and we are just one moment in its endless climb. Either way, entropy reminds us of something profound. Time is not just measured in clocks, it is written into the very direction of the universe's unfolding. Can time run backwards? It's a strange question, but one physicists dare to ask. Could time run backwards? Could entropy decrease, glass reassemble, smoke return to flame? The laws of physics at the microscopic level don't forbid it. At the quantum scale, particles can move both ways in time, as though past and future are not as rigid as we think. It's only when we zoom out into daily life that the arrow of time feels fixed. Some dream that in another universe time may flow in reverse, galaxies collapsing before expanding, lives lived backward from death to birth. To us it feels impossible, yet to the equations it is not. Even here, in our own universe, there may be moments where time's arrow bends, inside black holes or in the strange silence before the Big Bang, places where our familiar forward flow no longer holds. If so, then perhaps before the Bang wasn't a before at all, but a region where time was twisted, folded, or even reversed, an alien rhythm beyond our comprehension. Clues buried in cosmic background light. Though we cannot look directly before the Big Bang, we can listen for its whispers. The universe left behind a faint glow, the cosmic microwave background, like an after-image of its birth. This light is not uniform. It is filled with tiny ripples, patterns as subtle as fingerprints. Scientists study these ripples, hoping to find clues, scars perhaps, of what happened in the very first moments. Some even suggest that hidden within these ripples may be evidence of previous universes. Echoes imprinted into the glow, like shadows left behind on the walls of time itself. The search is delicate, almost like archaeology of the cosmos. Each faint variation is sifted, analyzed, compared, as scientists try to peel back the veil of creation. And while the secrets are not yet clear, one thing is certain: the light itself carries memory. Memory of when the universe was still young, and perhaps even whispers from times before time began. Quantum tunneling into being. Quantum physics tells us something extraordinary. Particles can sometimes appear in places they shouldn't be. This is called tunneling, slipping through barriers as though reality itself allows shortcuts. Some scientists wonder, could the entire universe have tunneled into being? It sounds absurd, yet the math allows it. Out of a quantum vacuum, a fluctuation could tunnel across the barrier of nothingness, igniting space, time, and everything that followed. Our Big Bang may have been a leap not from emptiness, but from possibility. Imagine a candle flickering in the dark. One moment there is no flame, and then, suddenly, light exists. Quantum tunneling suggests such leaps may not be miracles, but natural features of the universe's own rules. This vision of creation doesn't need a designer or an external trigger. The laws themselves may carry within them the capacity to birth worlds. The universe may have been destined to tunnel into existence simply because it could. If that is so, then before the bang was not a void, but a stage of potential energy waiting for one impossible step that paradoxically wasn't impossible at all. A universe from a fluctuation. At the heart of quantum theory lies another strange truth. Even in the emptiest vacuum, fluctuations happen. Tiny bursts of energy pop in and out of existence, too fleeting to notice. Some scientists believe our universe began as one of these fluctuations. This idea reframes the Big Bang. Instead of being sparked by some grand external cause, it may have been a simple fluctuation, small, random, and yet enormous in consequence. A tiny hiccup that grew into galaxies and life. It is humbling to think that something as vast as us could begin from something as delicate as a quantum whisper. But in physics, even whispers can echo across eternity. The question then becomes, why this fluctuation? Why one that grew instead of fading? Some theories suggest that certain fluctuations naturally stabilize, ballooning into universes, while countless others flicker out, never noticed. If true, then universes may be bubbling constantly in the background. Most vanish. A rare few, like ours, expand and last. Creation in this view is not an exception, it is happening all the time. The nothing that isn't nothing. When scientists talk about nothing, it's not the same nothing we imagine. To us, nothing means emptiness, a void. But to physics, nothing is a restless vacuum, alive with fields and energy, never truly still. This so-called nothing hums with potential. Virtual particles dance in and out of existence, as if reality itself cannot help but flicker. The fabric of space is not dead, it is a sea of possibilities, always moving beneath the surface. If that is the true nature of nothing, then asking what existed before the Big Bang becomes stranger. Perhaps the answer is the same thing that exists now, all around us, restless fields, bubbling with unseen energy. Our universe may simply be a condensation of this restless sea, like a droplet forming on a window pane. Nothingness, then, is not an absence, but a womb, a place where universes wait to be born. And so the haunting phrase, something from nothing, may not be a paradox at all. It may be the most natural thing in the cosmos. Vacuum energy, restless in silence. Physicists speak of vacuum energy, the lowest possible energy of space itself. It is not zero. Even in perfect stillness, the vacuum seethes with energy, like an ocean that cannot stop moving. This vacuum energy may have been the fuel of the Big Bang. A sudden release, like a spring uncoiling, could have driven space to expand in that first fiery instant. It wasn't created out of nowhere, it was released from a silence that was never truly silent. Imagine a bow, pulled tight, holding energy even when no arrow flies. The universe before the bang may have been such a bow, drawn back in timelessness until the string finally let go. Even now, vacuum energy remains. Some scientists call it dark energy, the mysterious force driving today's cosmic expansion. In that sense, the birth of the universe never really ended. The vacuum is still feeding its growth. And perhaps long after we are gone, it will continue. Silent, invisible, eternal, carrying the universe forward into a future without end. Particles, flickering in and out. In the quantum vacuum, particles are never truly gone. They appear, vanish, and reappear in a dance too quick for our eyes. These flickers, called virtual particles, may hold the key to the greatest mystery, the birth of everything. If the Big Bang began as such a fluctuation, then our universe may be the long-lasting child of what usually disappears in an instant. Most flickers fade, but ours expanded, stabilized, and became the cosmos we live in today. This vision reframes creation, not a singular miracle, but a rare survival, a fluctuation that endured instead of vanishing, carrying us with it into being. It's almost humbling to think the galaxies above us, the atoms in our bodies, the breath in our lungs, all may trace back to a flicker, a brief particle that refused to fade. And if particles are still flickering now, then perhaps new universes are being born constantly, right beside us, unseen. The cosmos may be a restless garden, always flickering, always flowering. Does nothing ever stay still? We often imagine nothingness as absolute stillness, but quantum physics suggests the opposite. Nothing is restless. Even in the deepest vacuum, energy flickers, particles rise and vanish, waves ripple without cause. Nothing is more alive than silence itself. This overturns our intuition. Stillness, it seems, may be an illusion. At the smallest scales, existence is never at rest. And if nothing is never still, then the birth of a universe is not a miracle. It is inevitable, a crest in a sea that never calms. Picture an ocean at night. From the shore it seems quiet, but beneath unseen currents churn. That is our cosmos, still on the surface, yet endlessly alive beneath. Creation may be the natural consequence of this hidden restlessness. If so, then the Big Bang wasn't a rupture in perfect stillness, but a natural release of energy, always waiting, always stirring, always ready to bloom. The question is not whether something comes from nothing, but whether nothing ever existed in the first place. Symmetry before the break. Physicists believe that in its earliest instant the universe was perfectly symmetrical. Forces were united, gravity, electromagnetism, nuclear forces, all woven together in a harmony beyond anything we know now. Symmetry is powerful. It represents balance, unity, simplicity, but nature, for reasons still mysterious, broke that symmetry. Forces separated, particles gained mass, the neat unity fractured into the diverse cosmos we see today. Imagine a crystal shattering. From one perfect shape, countless shards scatter, each reflecting light differently. The Big Bang may have been such a fracture, beauty emerging not from order, but from brokenness. Some scientists wonder why symmetry had to break. Was it random or necessary? Without the break, atoms would not form. Without atoms, no stars, no planets, no life. Our very existence depends on imperfection. So perhaps the deepest truth is this. The universe was born in symmetry, but it found meaning in its break, forces entangled as one. Before symmetry broke, all the forces of nature may have been one, not four, as we know them now, but a single, unified force. Imagine gravity, electricity, and nuclear energy woven together like threads in a single rope. This idea is called the grand unified theory, a dream physicists chase, hoping to stitch back together the fragmented laws we see now. If we can find this unity, we may understand the state of the universe before the bang itself. It is strange to think every falling apple, every lightning bolt, every fusion in the sun may once have been the same phenomenon, indistinguishable in the first instant of reality. And though today they feel separate, echoes of their unity remain. Quantum mechanics and relativity sometimes clash, but they also whisper of a deeper order, a reminder that the forces we see now are siblings, once inseparable. If forces were one before the bang, then perhaps the explosion was not the start of chaos, but the unfolding of hidden unity into diversity. The moment order fractured. In that earliest fraction of a second, something irreversible happened. Symmetry shattered, forces split apart, particles differentiated. The universe moved from simplicity into complexity, from unity into diversity. That fracture is the heartbeat of our cosmos. Without that moment, matter might never have formed. The split allowed particles to gain mass, to cling together, to weave atoms, stars, and eventually us. Brokenness became the foundation of everything we love and know. It's almost poetic. Perfection dissolved into imperfection, and from that imperfection came galaxies. It is as though the universe had to crack open to reveal its beauty. Scientists call this process spontaneous symmetry breaking. But to a poet it may sound like a fall into imperfection. And yet without the fall there would be no story, no fire, no life to witness the stars. The fracture was not a tragedy. It was the first act of creation, the first breath of separation. When the forces split, the universe took its first breath. Heat, energy, matter, all began to separate, giving rise to the laws that would govern forever after. It was the beginning of distinction, the moment this became different from that. Before that breath, everything was blurred, unified, indistinct. But in separation, identity emerged, gravity pulled, electromagnetism danced, nuclear forces bound particles together. Each found its role, each carved a path. It is strange to think how fragile that moment was. A slight difference, and no atoms might have formed. A tiny variation, and stars would never ignite. Creation hinged on delicate balances. And yet it worked. The universe took its first breath, and from it came all breaths that followed, ours included. The silence fractured, and the song began. We live as echoes of that first breath of separation. Every star, every life, every question we ask tonight, all trace back to that moment when the universe first decided to exhale. Philosophers on the edge of physics. Long before particle accelerators, it was philosophers who wrestled with the beginnings of existence. They didn't have equations, but they had questions, and sometimes those questions still haunt science today. Aristotle wondered if time could have a beginning at all, or if it must stretch infinitely in both directions. Descartes asked what nothingness really meant. Kant argued that the human mind may never grasp origins because we are bound by time while the cosmos may not be. Modern physicists often find themselves echoing these voices. The equations take us far but not past the singularity. And there philosophy returns, quiet, persistent, asking the questions numbers cannot. It reminds us that science and philosophy are not rivals but companions. Both circle the same mystery, one with data, the other with thought, and sometimes their shadows overlap in surprising ways. Perhaps the edge of physics is not an end, perhaps it is an invitation back into philosophy, back into wonder, back into the questions that first stirred us to look up at the night sky. What if time is an illusion? We live by clocks, hours, days, years, they shape our lives. But what if time itself is an illusion, a trick of perception, rather than a fundamental reality? Some physicists whisper this, and philosophers have long suspected it. Einstein showed us that time bends with gravity, slows near black holes, stretches with speed. If time can bend, is it real? Or is it just a measure of change, a story our minds tell to make sense of motion? In some theories, all moments exist at once, like pages already written in a book. We only read them in sequence, mistaking the reading for the reality. The flow of time may be a story of consciousness, not of the universe. This vision is unsettling, yet strangely liberating. If time is not real, then perhaps beginnings and endings are illusions too. The Big Bang may not be a start, it may just be one page in a book already whole. And if time is an illusion, then the question, what came before, dissolves, leaving us with something stranger. Perhaps there was never a before, only an always. The possibility of infinite pasts. If time is real, then another question emerges. Could the past stretch back forever? Not just billions of years, but without limit. No first page, no initial spark, just endless time already lived. Some models of the universe suggest exactly that. Instead of a beginning, reality may have always existed in some form, changing, shifting, but never vanishing into nothing. The Big Bang, in this view, was not the start, but a transformation in an infinite chain. It is hard to picture infinity. The mind tires, circling back, asking yes, but what before that? Yet perhaps infinity itself is the answer. There is no before, because time has no edge to fall off. This idea carries weight. It means our universe is not a miracle out of void, but part of an endless river. No beginning, no end, only flowing without pause. And if that is true, then our place in the cosmos is not at the start of a story. It is within an infinite, eternal story already ongoing, already alive, long before us. No beginning, just being. Imagine stepping into a forest with no clear entrance. Trees stretch in all directions. You wander and you realize the forest simply is. Perhaps the universe is like that, no beginning, no before, only being. Some scientists call this the steady state idea. Instead of a creation moment, the universe simply exists, eternal, uncreated, infinite. It doesn't need a cause because it was never absent. Existence is its own explanation. This vision is strangely calming. We don't ask what came before the forest, we accept the trees. In the same way, perhaps we should not ask what came before the cosmos. It may simply be. Of course, this challenges our instincts. Humans crave beginnings. We ask who, what, when, why. But maybe the deepest truth is that some things are not born because they never died. They exist beyond the rhythm of birth and death. If so, then the Big Bang is not the start of being. It is a shift within being, a change in something that has always been and always will be. Consciousness before creation. Here's a radical thought. What if consciousness existed before the universe? Some philosophers and even physicists dare to wonder if awareness itself is more fundamental than matter. If so, then the Big Bang may not have created consciousness. It may have been shaped by it. Reality itself could be the unfolding of awareness, expressing itself as matter, energy, space, and time. In this vision, the universe is not a machine. It is a mind. It is an ancient idea found in Vedanta, in mysticism, in philosophies across the world, that mind precedes matter, that thought gives rise to being. Modern science rarely accepts it, yet it lingers, persistent, unshaken by centuries. And when you close your eyes and imagine before the bang, perhaps what you glimpse is not nothingness, but awareness, a silent witness, timeless, waiting for form, waiting for light, waiting for stars. If consciousness came first, then we are not accidents in a void. We are fragments of the very awareness that dreamed the cosmos awake. Did the universe dream itself awake? Some thinkers imagine the universe not as a machine, but as a dream. A dreamer, asleep in silence, suddenly stirs. And in that stirring, galaxies bloom. The Big Bang, then, may not have been an explosion, but an awakening. This vision is old and new at once. Mystics have whispered it for centuries, and some modern scientists hint at it too. Perhaps existence itself is the dream of reality, unfolding like a story being told to itself. It makes you wonder, if the universe is a dream, then who is the dreamer? Is it a god, a field of consciousness, or the universe itself? When you look at the stars, the thought can feel strangely familiar, as though you too are part of the dream, and your act of noticing it is the dream noticing itself. And maybe, just maybe, every sunrise, every heartbeat, every question we ask is the universe whispering, "I am awake," the role of observation. Quantum mechanics holds a strange rule. Until something is observed, it exists only as probabilities. A particle is not here or there, but both, until measured. In some interpretations, observation itself gives reality its form. This raises a startling thought. Before observers, before consciousness, what was reality like? Was it a haze of probabilities, undefined until awareness entered the scene? If so, then consciousness may not be an afterthought of the cosmos, but a co-creator. The act of observing shapes the very thing observed. In this way, life is not passive, it is participatory. It suggests that the universe, in its earliest moments, may have needed observation, however subtle, however hidden, to crystallize into what we know today. And if that's true, then our role as witnesses is not small. We are participants in creation, eyes through which the cosmos continues to make itself real. Would the universe exist without witness? This leads to one of the most haunting questions. If there were no observers, would the universe exist at all? Or would it remain a cloud of possibilities never fully realized? Some scientists argue yes, the universe is independent of us, but others lean toward a stranger answer, that reality requires a witness, however small, to collapse its haze into form. In that case, even before humans, perhaps the first atoms acted as witnesses, or photons themselves, the first light, may have been the eyes of the cosmos, crystallizing the story as it unfolded. The idea is unsettling and beautiful. It places awareness not at the end of creation, but woven into its beginning like a thread hidden in the fabric of time. Perhaps we do not stand outside the universe observing it. Perhaps we are the way it observes itself. Are we remembering or imagining? When we ask what came before the Big Bang, are we truly discovering or are we remembering? Some traditions suggest that deep within us the memory of beginnings already lingers, etched into the consciousness that is older than stars. It is difficult to separate memory from imagination, yet both serve the same purpose. They take us beyond the present, into the unseeable. When we picture the void before creation, we may be brushing against something buried in our own being. Science calls it speculation. Philosophy calls it contemplation. Mystics call it remembrance, but perhaps they are not so different. Because when you close your eyes and imagine nothingness, you might notice a paradox. The very act of imagining fills the nothing with something. Memory and imagination entwine until you cannot tell them apart. And maybe that is the secret, that in wondering about the beginning, we are not inventing it. We are remembering a story that has been whispered in us all along, the strange intuition of always. Even as we ask for beginnings, we carry within us an intuition of always. Something in us resists the idea of nothing. We feel, deep down, that there must have been something, some presence, some being, forever. This intuition shows itself in myths of eternal gods, in science's cycles of universes, in our personal inability to accept absolute void, our minds recoil at nothingness, leaning instead toward the idea of always. It may not be proof, but it is telling. Human beings across cultures and centuries converge on the same feeling. Existence cannot vanish. Something must endure. Perhaps this intuition is not illusion, but recognition. Maybe we sense, in quiet moments, that reality itself is eternal, that it never truly began and will never truly end. And if that is true, then the Big Bang was not the start of existence. It was the start of this chapter in an always that never sleeps, searching for evidence in silence. The deeper scientists look, the more they find silence. Not the silence of absence, but the silence of mystery, an emptiness that may still carry clues. Every telescope, every experiment is really a search for whispers in that silence. What are they listening for? Patterns too faint for the naked eye, signals buried in the static of the cosmos, scars in the light left behind by creation. The silence, they believe, is not empty. It is filled with secrets waiting to be uncovered. It's like listening to an old vinyl record with cracks and pops. The imperfections may contain the history of how the song was recorded. In the same way, silence itself may hold the fingerprints of what came before. Yet silence is stubborn. It refuses to give answers easily. For every clue, a dozen questions appear. Still, humanity keeps listening, keeps searching, because within silence lies the only place left to look. Perhaps that is the paradox. The silence before time may be the loudest mystery of all, humming just beyond what we can hear. The limits of the cosmic horizon. We often imagine the universe as infinite, but our view of it is not. Beyond a certain horizon, light has not had time to reach us. That horizon is the edge of what we can see, the cosmic horizon. It's like standing on the shore of an ocean at night. You see only as far as the waves reflect the moonlight. Beyond that, the ocean stretches on, but it is hidden. Our cosmic horizon works the same way. This limit makes the search for what came before the Big Bang even harder. If the clues lie beyond the horizon, we may never see them, no matter how powerful our instruments become. And yet, scientists refuse to stop looking. They study the horizon itself, examining the faintest ripples, hoping to find shadows or distortions that hint at a larger truth just beyond sight. The horizon humbles us. It reminds us that we live inside a bubble of knowledge surrounded by vastness we may never touch. But it also teases because horizons, by nature, invite us to wonder what lies beyond, shadows hidden beyond what we see. Though the horizon sets a limit, some scientists suggest it may still cast shadows inward. Just as light passing through a curtain leaves patterns, other universes or earlier states may leave imprints on ours. These shadows would be faint, subtle distortions in the distribution of galaxies or tiny asymmetries in cosmic background light. Detecting them would be like finding footprints in sand, half washed by the tide. The search for such shadows is delicate work. Entire missions are devoted to scanning the sky for unusual alignments, unexplained cold spots, or ripples too structured to be random. Some think these might be hints of collisions with other universes, or echoes from a pre-Big Bang state. Others argue they are just statistical noise. The debate continues with evidence as thin as smoke, yet too intriguing to ignore. And as we search, the shadows remind us that what we see is not all that is. Beyond sight, beyond measure, there may be realities brushing up against ours, leaving whispers like fingerprints on glass, patterns that hint of other worlds. From time to time, astronomers discover strange patterns in the data, a cold spot larger than expected, a region of sky that seems oddly uniform, ripples in the cosmic microwave background that defy easy explanation. These patterns spark wild ideas. Could they be evidence of other universes brushing against ours? Could they be scars left by collisions when bubble universes in the multiverse briefly touched? Skeptics caution that randomness can produce illusions. But the allure of meaning is strong. When we see patterns, we instinctively feel they tell a story. And perhaps in this case, they do. Even if the evidence is faint, these patterns keep alive the possibility that our universe is not alone. They remind us that what we see in the sky is not only light, but memory, records of cosmic events we may not yet understand. One day, a pattern too precise to dismiss may emerge. Until then, the strange marks in the data remain like hieroglyphs, inscriptions in the sky waiting to be deciphered. Gravitational waves from before time. Light can only tell us so much, but gravity, ripples in space-time itself, may carry secrets from before the Big Bang. These ripples, called gravitational waves, move through the fabric of the cosmos like echoes through stone. In recent years, scientists have detected them from colliding black holes and merging neutron stars. But some hope to find even older waves, waves born not from stars, but from the very birth of time itself. Such primordial gravitational waves would be a direct whisper from before light, before matter, before everything. Detecting them would be like hearing the heartbeat of the universe's earliest moments. The search is delicate. Instruments must measure shifts smaller than a proton's width, sifting cosmic silence for vibrations that may be older than galaxies. It is the hardest listening humanity has ever attempted, and yet if those waves are found, they may carry the first true evidence of what existed before the Big Bang, a voice echoing across eternity, finally heard,